Hi, I am Jonathan Cast, and this is Global Skirts. Um, so I want to talk a little bit about unit testing. Testing in general and unit testing in particular is a big topic. Gets a lot of discussion, a lot of debate back and forth. So I want to throw my 2 cents in there. So the first point of kind of confusion is, what is unit testing exactly? What do we mean when we talk about unit testing? And there's basically two approaches to this. The more dogmatic, the more extreme position tends to be that a unit test is a test that only exercises and only tests the code that's contained within a single module of the program, single localized piece of your source code, whether that be a function or a source file or a class or whatever it is, which I'm going to refer to as mockist unit testing. Technically, you don't have to use mocks if you are very thorough about your dependency injection. But I'm going to refer to it as mockist unit testing just for the purposes of this video. And then the other view is that a unit test is a test that calls the API of a particular module. But if that module has dependencies, it allows that module to go ahead and call those dependencies. And we're finding out what's the real functionality with this module and the dependencies that it's actually going to use in the real program. So I'm just going to come right out and say it. In a dynamically typed language, mockist unit testing, if you really mock every dependency of a system in a normal system, is a colossal waste of human energy. It is just beyond reason for the value you're actually going to get. Because what ends up happening is you can add a parameter to a function in one module, not change any of its dependencies outside of its own tests, run the full test suite, get passing tests, and think, oh, my program will still work. And every single dependency on that module is going to break because you forgot to add the new parameter to any of the callers. So, especially when people say, well, we'll just use unit testing as a substitute for static typing, which I'll get to in another video, but this just absolutely makes no sense. The other kind of unit testing, you could say that it's sort of integration testing. And in a way, it sort of is. But that's more of a good thing than it is a bad thing. The advantage that integration testing has over unit testing, integration testing is testing properties of the system that you actually care about, right? So you've got this system, you believe that this system provides certain kinds of business value to your organization. You base that belief on a belief that the system has certain properties, exhibits certain behaviors, and then an integration test actually verifies that it has the properties and exhibits the behaviors that you think provide business value to your company, to your organization. So if an integration test fails, you actually know that you have a problem in the system, that your system is not doing what you think it's going to do. Whereas many times a unit test is just testing, hey, I wrote the code I expected to do. Why did I need to write that code? That's not really clear. That doesn't necessarily have anything to do with whether you get a green bar or a red bar. So overall, you're better off using integration tests that exercise the whole system and that look at the system from the perspective of the actual users or the actual business. And that should be your main testing strategy. The degree to which you can actually build tests like that is going to depend on the application, obviously. If you've got a legacy system, it may be really hard to build those integration tests because you may have to do much more work to put together an overall system. Sometimes that's an indication that your piece of software is hard to use, and that you need to simplify things. You need to make things easier to use, and then they'll end up being more testable. Some properties of a system are really hard to simulate from that top-down approach. And so then you have to write your test to a lower level API within the system where you can set up the conditions you want, you can simulate the behavior you want to test. But as much as you can, you still want to avoid mocking or testing a module just because you want to test that particular module, even though you want to avoid writing tests just to have tests. You want to write tests because there's definable value to the behavior that you're testing, regardless of what level the system the tests are getting into to access the code at. So there's a belief out there that you need to have 100% test coverage for your test suites. And the concept is that if you write a test for every module, you write an assert that calls every function, that you're automatically going to get 100% test coverage. And that's true. But the problem you run into is if it automatically gives you 100% test coverage, in a way you're almost cheating, and you're not necessarily getting the value that coverage is supposed to give you. What you really want, what's more important than anything else, is to have 100% test coverage of your specification. Everything that needs to happen for your code to be correct needs to have a test. You want 100% test coverage for your real business value. So if you have a regression that affects the business, you find out about it. And then you want to have 100% code coverage for that test suite, because if you've got code that isn't really providing identifiable business value, just get rid of it. If it doesn't affect the user can't tell it's gone, get rid of it. It's just dragging you down. And so a lot of times a good integration test suite will help you with doing things like finding dead code. Oh, this module isn't used anymore. How do I know? Well, my integration tests that are exhaustive don't exercise that code, so none of the entry points into my function ends up actually calling it. So get rid of it. That's an idea that actually comes from a Perl developer by the name of Ovid, who's a major figure in the Perl community. And then, of course, as he also points out, if you have a test module for every single implementation module, you're never going to find out dead code by running your test suite that way. And if you have mocks for every place that uses that module, you're definitely not going to find it out. So that's an advantage to not having unit tests. So that's kind of my opinion. If you can write integration tests around something, integration tests are going to be more effective. They're going to be cheaper, easier to write, and you can spend your time doing what actually matters, which is writing the code to implement the features. So as always, I am interested to hear your thoughts, your counter-arguments, any experience you've had that goes one way or the other. This is Jonathan Cast for GlobalScript, signing off until next time.